Chapter 9.2, we are going to be talking about what is a matrix. Okay, what is a matrix? Alright, one matrix, the plural form, matrices. So one matrix, two matrices. So when you hear that, you'll know what I'm talking about. Alright, so what is a matrix? Alright. A matrix, it's an arrangement of numbers. Okay? It's an arrangement of numbers, and the way that we arrange those numbers is we put them in rows and columns. Okay? So, a matrix is an arrangement of numbers in rows and columns. Now, sometimes these numbers, they can also be variables. Okay? So, this would be an example of a matrix. In a matrix, we put them in these brackets like this. Right? We're going to put them in these brackets, and this would be an example of what a matrix might look like. Okay. A, B, C, D, E, F. This could be a matrix. Right, here's an arrangement of numbers, in this case it's variables, in rows and columns. Alright? Now, each of these numbers or variables or whatever we put in this matrix, each of those is called an element. Okay? So an element is just what I said, each number or variable, okay, in the matrix. Right? So we've got a matrix, it's made up of rows and numbers, and each of the rows and numbers is made up of elements. Okay? So, let's talk about when we want to know what the size of our matrix is, or we call it the dimensions. Right? The dimensions of our matrix. To find the dimensions, we classify or label it rows by columns. Okay? The number of rows by the number of columns. Like when you see like a 2x4 piece of wood, the 2x4 is the dimensions. Okay, so we're going to be talking about the dimensions of our matrix in rows by columns. All right? So let's think. Rows go in the horizontal or the x direction. Okay? That's a row. And a column goes vertical or in the y direction. Okay? So rows go horizontal, columns go vertical, up and down. So in this case, when we're looking at this matrix, first of all, we're going to look and see how many rows does it have. Well, it's got 1 row, 2 rows, 3 rows. So it's got 3 rows. Right? Then we use an X, for the by part. And then we're going to look and see how many columns we have. So we've got 1 column, 2 columns. So this matrix here that we drew would be a 3x2 matrix. Right? That would be the dimensions of our matrix here. Right? Let's look at another matrix. We've got this matrix. 2, 6, 5. Right? And we want to find the dimensions. So the first thing we're going to look for is see how many rows do we have? Remember, rows go horizontal. So in this case, we just have one row. Now let's see how many columns we have. Right? Well, we've got one column, two columns, three columns. So this matrix here would be a 1 by 3 matrix because it's got one row and it's got three columns. Okay? Even though there's only one number in each column, it still is a column. Okay? Alright, so when might we use a matrix? Okay? Well, we may use a matrix to represent points on a graph. We may use a matrix to represent points on a graph. Okay. For instance, let's say we've got 3 points that make up a triangle. Okay, point A, point B, and point C. Okay. Say point A is at 1, 5. Point B is at negative 2, 10. And point C is at 6, 4. Okay. We've got those 3 points, A, B, and C. We can fit those 3 points into a matrix, right? So here we go. The way that I could put these into a matrix, I could make myself a matrix here. Here's our brackets. And on the top row of my matrix, so this top row, I could make those my x values. Right? I could make the top row of each of my points the x values. Okay? So then the bottom row, I could make my y values. Okay? So how do we know that there's 2 rows and whatever? Well, the reason that we're only going to use 2 rows is because each point has an x value and it has a y value, right? So we're going to put the x values on top and the y values on the bottom. So this is what our matrix would look like. To put point A into our matrix, the x value of point A is 1. Okay, I'll even put an A up here so I know where it came from. And the y value of point A would be 5. Okay? So then on to point B. My x value to point B is negative 2, so I'm going to put that in the top row. The y value of point B is 10, so I'm going to put that in the bottom row. Then move on to point C. Our x value is 6. Goes in the top row. Our y value is 4, so it's going to go on the bottom row. Right? So we could use a matrix to represent points on a graph like we did here. Okay, point A, point B, and point C. Okay? Alright, now, when we want to add or subtract matrices, okay, adding and subtracting matrices may be the easiest thing that we've done all year long. Whoops, there's a C there. When we want to add or subtract matrices, one thing must be true. Okay, here's our one rule. The 2 matrices must have the same dimensions. In order to add or subtract 2 matrices, they must have the same dimensions. Okay, so let's look at this matrix up here. This matrix had 1, 2 rows, and it had 1, 2, 3 columns. So our matrix up here was a 2 by 3 matrix. Right? So if I wanted to add a matrix to that, it would have to be a 2 by 3. So for example, let's say we have this matrix. 2, 1, 10, 4. Right? And we want to add this matrix to it. 5, 9, -2, 8. All right? The first thing that we have to do is we have to find out, can I even add these two matrices together? So the way that we're going to do that is we're going to find out if they have the same dimensions. Okay, so I'm going to look at my first matrix, and I see that it has 1, 2 rows, and it has 1, 2 columns. So this is a 2 by 2. When I look at this matrix, it has 1, 2 rows, and 1, 2 columns. All right? So, are these the same? Yes, they are. A 2 by 2 and a 2 by 2. So that means, hey, I can add them. All right? Now the way that we add them, we just add the numbers that are in the same position. So for instance, 2 is in the top left. We're going to add it to 5 that's in the same position, top left. All right? So, 2 plus 5 is 7. 10 plus -2 be 8. 1 plus 9 is 10. 4 plus 8 is 12. Okay? So this is what I like to call the answer matrix. This is your answer. Right? And you'll see that when we add or subtract, the dimensions of our answer matrix are also the same as the dimensions in the other two matrices that we use to add. Right? So let's look at another one. Let's say we've got this matrix. Okay. Plus that matrix. 1, 4, 5 plus 10, 8. Alright? Now, this is what we want to do. First, we've got to check and see, do they have the same dimensions? Alright? Well, this one has 1 row, and it's got 1, 2, 3 columns. So that's a 1 by 3. This matrix here, 1 row, and it has 1, 2 columns. Are these the same? No, this is a 1 by 3 and this is a 1 by 2. Right? So we can't do this one, so we're just going to put NA next to this. Right? That's our answer. We can't do it because if I wanted to explain, I would say because my two matrices don't have the same dimensions. Right? These two have the same dimensions, so we could add them together. These two, they didn't have the same dimensions, so we couldn't do it. Right? Let's try one more. Let's say we have this 2, 5, 9, -1, 3, -10. We've got that matrix. And this time we're going to subtract. Again, this one's 2, 5, 9, negative 1, 3, negative 10. All right, over here, let's go 1, 4, 8, negative 2, 1, and 0. Alright, so we've got these two matrices, and we're going to see if we can subtract them. Okay? Well, the first thing we've got to do is we've got to see if they have the same dimensions. Well, this one has 1, 2, 3 rows. Okay? 3 rows, and it's got 1, 2 columns. So it's a 3 by 2 matrix. When we look at this matrix, 1, 2, 3 rows, 1, 2 columns. Okay. So do these match? Are these the same? Yes, 3 by 2, 3 by 2. So that tells us we can subtract them. All right, so now let's subtract them. 2 minus 1. Okay, 2 minus 1 would be 1. 5 minus negative 4 would be 9. 9 minus 8 would be 1. Okay. Let's go to the next column. Negative 1 minus negative 2 would be positive 1. 3 minus 1 would be 2. And negative 10 minus 0 would be negative 10. Right. So this would be our answer matrix, and it is also a 1, 2, 3 by 1, 2. Okay? If these are a 3 by 2, then our answer is going to be a 3 by 2. Okay? Adding and subtracting matrices, really easy. Check to see if they have the same dimensions. Okay? If they do, you just add the numbers or subtract the numbers that are in the same position. If not, then we can't do it like this one. Okay? Now, when we multiply matrices, it's a little bit different. Okay? You really need to pay attention when we talk about multiplying matrices. Okay, because it can get confusing. Alright, the condition that we have to follow when we multiply matrices. Okay, when we multiply, if I have two matrices, okay, so I've got this matrix A and this matrix B. In order to multiply two matrices, okay, the columns of A, okay, so however many columns are in matrix A, has to be equal to the rows of matrix B. Okay? So the columns of A have to be the same or equal to the rows of B. Right? So let's do this one. Let's say 2, 10, 4, 1. And then times negative 1, 8, 5, 2. Okay? So 2, 10, 4, 1, negative 1, 8, 5, 2. Okay, we've got these two matrices. And what we need to do first is we need to check their dimensions. Okay? Remember, rows by columns always. Alright? So, our first matrix has 1, 2 rows, 1, 2 columns. Second matrix, 1, 2 rows, 1, 2 columns. Alright? So this is how we're going to check to see if we can multiply them. The columns of A is this number, and the rows of B is this number, these two inside numbers. So what we're going to do is we're going to look at these inside numbers. If these inside numbers match, then we know that we can multiply these together and it'll work. Right? In this case, they are the same. Okay? This is 2 and that's 2. They're the same, so we know, yes, I can multiply. If they weren't the same, then we would say NA. Right? We can't do it. So the inside numbers, if they match, they tell us that we can multiply our matrices together. The outside numbers are also going to tell us something. Okay? The outside numbers are going to give us the dimensions of our answer matrix. Okay? So we know that our answer matrix is going to be a 2 by 2. Right? Okay, so in order to multiply matrices together, right, I want you to put your 2 pointer fingers out like this. Okay? Actually point them down like this. In order to be able to multiply, you need to be able to take your left pointer finger and it needs to move this way, horizontal. Okay? And your right pointer finger needs to be able to move vertical, up and down. Okay? And you need to be able to do it at the same time. Okay? Like this. See that? Alright? It's kind of like you're picture yourself holding a steering wheel and you're taking a right turn. Okay? Taking a right turn. Now why are we doing that with our fingers? Because that's how we're going to multiply a matrix. Okay? We're going to start and we're going to use this first row of our matrix, okay, with each column of this matrix. Alright? Stay with me. Here we go. So I'm going to start with my first element here, which is 2, and my first element in this column, which is -1. Okay? I'm going to multiply those two numbers together. So 2 times -1 would be -2. Okay? 2 times -1 is -2. Right? Now we're going to do a little maneuver with our fingers. Remember, our left finger is going to go to the right, and our right finger is going to go down. Okay? And we're going to stop when we get to the next element. So here we go. I'm going to slide over. And now I'm going to say 4 times 8. 4 times 8, which would be 32, and I'm going to combine it with the -2 that we just had. Alright? Okay. So this is kind of our scratch work right here. And then this will be our answer, our final answer matrix. So we know that -2 plus 32 gives us 30. Okay. So that's the first element in our answer matrix. Okay, we did 2 times -1. We did our little finger maneuver. Slide down and over. And we get 4 times 8, which is 32. We add those together. Okay, and we get 30. Alright? So now I've used this row with my first column. Well, now I'm going to use this row with the next column. So I'm done with this column for now, and I'm going to move to the next column, which starts with 5. All right? We're going to do the same thing. First element in this row, first element in this column. 2 times 5, which would be 10. Okay? And now we're going to do our little finger maneuver. Slide over and down. 4 times 2 is 8. So we get 10 plus 8, which would be 18. Okay? So we got 30 by saying 2 times negative 1. We do the finger maneuver. 4 times 8, which is 32. We add those together, get 30. So then we went and we used the first row and the second column. 2 times 5 is 10. Slide over and down. 4 times 2 is 8. So 10 plus 8 is 18. Right? So now we've used this row with every column in our matrix. Okay? So we're done with that row now. We used that row with every column. So now we're done with this row and we're going to move to our next row. Right? So we got 10, and we're going to start here with our first column. So we're going to say 10 times negative 1, which would be negative 10. Okay. Now we're going to do the finger maneuver, slide over and down. 1 times 8 is 8. Okay. So negative 10 plus 8 would give us negative 2. Right? So now we've used this row with that column. Now we've got to use this row with our other column. So we're going to start with the first element in each. So we get 10 times 5, which would be 50. Then we're going to slide over and down. 1 times 2 is 2. So we add 50 plus 2, which would give us 52. Huh? So this right here would be our answer matrix. Okay. You've got to be able to do a whole finger maneuver thing where we move over with our left finger and down with our right finger. Alright? It's kind of confusing, but you just got to practice and get the hang of it. So here we go. Let's try another one. Go 2, 3, 5. Times 2, 10, 8, 1, 6, negative 2. All right. So our first matrix, 2, 3, 5. Our next one is 2, 1, 10, 6, 8, negative 2. Okay, so first thing we've got to do is we've got to look to see if we can even multiply these together. So let's find the dimensions. The dimensions of our first matrix. How many rows? 1, 2, it has 3 rows. Okay. How many columns does it have? Well, it's just got the 1 column. Right? So this is a 3 by 1 matrix. Let's look at our second matrix. How many rows? 1. It's got 2 rows. And how many columns? 1, 2, 3 columns. Alright? So like we did up here, we're going to check and see, do our inside numbers match? In this case, do they match? No, they don't. So automatically we can say it's not possible. NA. Okay? NA, we can't do it. Right? Can't do it. And the reason is the number of rows in our first matrix don't match the number of, the number of columns in our first matrix don't match the number of rows in our second matrix. Okay? They don't match. These outside numbers match, but that doesn't matter. The inside numbers have to match. Alright? So let's try one more where the inside numbers do match. Here we go. Let's say 2, 3, 5 again. And let's give it another column. Let's say 1, negative 2, and 10. Alright? So 2, 3, 5, 1, negative 2, 10. And we're going to multiply that by our matrix we had up here. Okay? 2, 1, 10, 6, 8, negative 2. Alright? So here we go. Let's look at the dimensions of our first matrix. Okay, the dimensions of our first matrix. Remember, rows by columns. So how many rows? 1, 2, 3 rows. Okay, let's see how many columns. 1, 2 columns. So our first matrix is a 3 by 2 matrix. Let's look at the second one. How many rows? 1, 2 rows. And 1, 2, 3 columns. Alright? So here we go. We got to check the inside numbers. This one's a 2 and this one's a 2. Do they match? Yes. So we know that we can multiply them together. Right? So now let's look at our outside numbers. 3 and a 3. Remember the outside numbers, like up here in our other example, the outside numbers give us the dimensions of our answer matrix. Okay? So in this case, we know that our answer matrix is going to be a 3 by 3 matrix. All right? So again, we use this as our scratch work and in order to find our final answer matrix. So here we go. We're going to start with our first row and our first column. So fingers on the first elements. 2 times 2 is 4. Now, finger maneuver, slide over and down. 1 times 1 is 1. Right. So here will be our final answer matrix over here. We know that it's going to be